The learning intention of the lesson is to calculate the volumes and capacities of other solids, so cones, spheres and pyramids, as well as composite shapes. The first one we're going to look at is the volume of a cone. Now, as you can see in the diagram below, we actually have a red cone sitting within a cylinder. Now, both of these two shapes have the same radius and they have the same height. And so what we know about this is for a cone, and in fact when we look at a pyramid in a moment, it's the same as well. For a cone or a pyramid, their volume is 1/3 of the volume of the shape they sit inside. So in this case, we're talking about this cone's volume being 1/3 of the volume of a cylinder. Now, the volume of a cylinder is based on the area of its base, which is our circle. And so we know the area of a circle is pi r squared. And then we are multiplying by its height. Okay, so when we talk about the volume of the cone, it's exactly that, but 1/3. So the volume of a cone is 1/3 of pi r squared times the height. So to look at an example of that, and we'll leave that little formula on the screen. So for our cone below, we can write our rule. So our first step is always to write the rule. So volume equals 1/3 pi r squared height. And we know that each of those are actually being multiplied. We just don't write those in maths. So our second step is then to identify which variables we have, what's our radius and what's our height, and then to substitute those values into the formula. So for this particular example, they've given us the radius. So the radius in this case is 8.4 centimetres, and we know a radius is halfway across the circle from the centre to the outside. So if we were given a diameter, which a diameter would be a circle, and we would be talking about the whole way across, passing through the centre, our radius in that case would have to be the diameter divided by 2. Okay, but for this example, we don't need to do anything. It's already there. We also need to know our height, and in this case, our height is 15. So we're going to go 1/3. As I said before, we need to go times pi times, now the radius being 8.4 squared, times the height, which is 15. We're then going to put that into the calculator. Now, to put 1/3 into the calculator, I just simply go 1 divided by 3. Alternatively, you can use your fraction button, and that would work as well. So you'd hit 1 and then you'd hit your fraction button, which looks often, depending on which model of calculator you have, but something like that with the A and then a B and a C, or it may look something like this with the box over another box and one of those being coloured in. So they're your fraction buttons. So you could hit 1, hit that button, and then 3 times and continue on. So when we times, we then also use our pi button. So you should have your pi button on the calculator. And then we times 8.4. Now again, to get the squared, we actually have a button for that, and it often is an x squared. Okay, so that's our squared button. So we would hit the x squared button after 8.4 and then times 15. So we've got $1,108.35. Now this question asks to go to 2 decimal places, and so we then need to round off. The third digit would be a 3. Because it's a 3, we actually round back, so we keep it as the 0.35. And then units are going to be centimetres cubed. All right, perfect. So the next example we have is the volume of a pyramid. So as I said before, a pyramid works the same way. It's at 1/3 of whatever the volume is of the prism it sits within. So a prism may be a rectangular prism like shown, but it could be a hexagonal prism. It could be all sorts of shapes. And so we need to be able to, again, say it's 1/3 of the area of the base times the height. So in this particular example, we have a rectangular prism, which the volume of that is length times width times height. So the rule becomes 1/3 length times width times height. Okay. So in this example, we've got two examples to look at. For the first one, we can see that we have 17.5 centimetres and 17.5 centimetres for our base. So we actually have a square-shaped base, and then we know our height of the pyramid is 11.2. Now, with our rule, we can write our rule first. So volume equals, it's always 1/3, and then we've got our area of the base. So you can write length times width times height if you'd like. Alternatively, you might prefer to go side squared because the base is a square, times the height. It's up to you which one you feel more comfortable with in this situation. They'll both give you the same answer. So I'll use the first one, 1/3 times, now our side is 17.5 squared because it would be 17.5 times 17.5 times, and our height is 11.2. So again, to put that into the calculator, so we're going to put in 1/3. So again, you can use your ABC button, your fraction button, or you can do 1 divided by 3 times 17.5. Use your x squared button on the calculator, and times 11.2. So our answer for that is 1,143 and it's 3 recurring. So 3, it's asked us to go to 2 decimal places. So we'll leave it there. And it's centimetres cubed being volume. Now, you'll notice that I've put in a shape here. And it's a squiggly equal sign. That just means approximately equal to. And we use that because of the fact that we were rounding. All right, so from there, our last example is a hexagonal based pyramid, and this time we actually don't need to work out the area of the base because they've just given it to us. So our rule again is volume equals 1/3 the area of the base times the height. So we go 1/3 times, now we can just simply put in 122 times the height, which is 12, and again 1 divided by 3 times 122 times 12 gives us 488 centimetres cubed. All right, so that one's quite a simple one. So just to summarise for our cones and our pyramids, working out the volume, we go 1/3 times the area of the base times the height. Our final example is for a sphere. Now, the volume of a sphere is 4/3 pi r cubed. Okay, so in this particular example, they've given us the radius of 2.5 centimetres, and if we were given the diameter, we would take the diameter and we would divide by 2, which would give us the radius. So we're going to substitute our values in. 4/3 times pi times 2.5 cubed, and we're going to go approximately equal to, because using pi we end up with a decimal. So 4 divided by 3, or again you can use your fraction button, times pi times 2.5 cubed equals, and we've got 65.4. Now it's 449. Again, we're asked to go to 2 decimal places. So 449, the 9 tells us to round up. So we actually need to make this 4.5. And then the units, centimetres cubed. Thank you for listening.